work done by any force, is the integral of the product of the force, the scalar product of the force, times the displacement, dr. This is the definition, which is the same than the integral of f dr cosine theta, where theta is the angle between the force and the displacement, delta r. This is the definition of work, generally speaking. Because it's the integral of f dr, we can say that generally, if we have a graph Bf versus T, will be the area under the curve. Area under the curve, which is integral. So if we have f given and x given, and this is the function, this work, this area, will be the work, which is a positive work. And this area will be negative work. It's a scalar. The work is a scalar. And the reason that it's positive is a scalar that can be positive and negative is because sometimes the work is, by definition, work is the amount. So this is the mathematical definition. But the definition of work is the amount of energy transfer. Amount of energy transfer this is the amount of energy transfer. Now, the energy sometimes can be transferred into the system. So if this is the system, and I apply the force, and I move this, and I'm doing mechanical work. So the mechanical work is the amount of energy transferred from the surrounding into the system. The system is what we are studying. If we are studying the motion of the chair, so the amount of energy that I am putting into the system will be positive. The amount of energy going away from the system will be negative. This is the way that we describe positive work or negative work. The amount of energy entering the system will be positive. The amount of energy going away from the system is negative. And that's the definition of mechanical work, the amount of energy transfer. How can we calculate with this formula? If the force is not constant, the force is any force, or in general, the force is constant, we can use also the integral. This is the definition of work. Now, what will be the work done? So, if this is the definition of work, let's say that I give the force 3I, let's say the 3 T squared I plus 2J, and the displacement, and I have this. So let's say for instance, let me just give in one dimension. 3T squared plus 2T plus 1. This is the force. Let's say that is in the x direction. I want to find the work. How can I find the work? The work, if the force is not constant, I just integrate. What is the integral of this? 3T squared plus 2T, my bad, 3x squared as a function of x, 3x squared as a function of the displacement, 2x plus 1. So it will be 3x squared plus 2x plus 1, since it's I and the displacement is along x, is also I. The scalar product of this I dot I is 1, you know that. So will be the work will be just the integral. What is the integral of 3x squared? 3x cubed over 3 plus 2x over 2 plus x. Since we go from 0 to whatever point, 0 to 3 meters, you can find what will be the area under the curve from 0 to 3 meters. If you get that, that will be the amount of work or the amount of energy transfer. This is in case they give the force as a function of x. This is the definition of work. You just need to get the integral. If the force is given and as a function of x. Definition of work. The second thing we need to know is how to get the work if the force is constant. So how to find the work if the force is constant. So let's say the force is constant. Any force constant. This I means any particular force. So if the force is constant, the definition of work, according to here, will be if it's constant, can I pull out of the integral? I can pull out of the integral f. So will be f times the integral of dr. What is the integral of dr? R or delta r. If it's from r initial to r final, will be delta r. So will be f times delta r, the scalar product, which is the same that f delta r cosine of the angle between where theta is the angle between f and delta r. In other words, if we have the force here and the displacement here, what will be the work, or how can I find the work? Will be the scalar product. And we learn that the scalar product of A dot B is AB cosine theta, which is what we have here. So will be the work will be the product of F delta X cosine of the angle. What angle? This angle. This is in case that we have the force. What will be the unit of work? If the unit of work, if work is energy, will be joules. So the unit of work will be the force, which is in Newton, times the displacement, which is in meter, which is this Newton times meter from now on will be called joule. And joule is equivalent also, since Newton is kilogram times meter per second square, and we multiply by meter, this is the same. So all these three units are equivalent. So by definition, what will be the joule? By definition, joule is the amount of energy. Joule, 1 joule is the amount of energy that I will spend when I move with 1 Newton force this object for 1 meter. So if I am able to move with 1 Newton force for 1 meter this object, I will spend 1 joule of energy. This is the definition of joule, which is there. The amount of energy needed to move 1 object for 1 meter with a force of 1 Newton. So if you do that, you will spend 1 joule. Okay. By definition, that is the definition of work. How to apply this definition? Very simple. Let's do an example. We have example 1 for work.